I'm curious, how many people here are dealing with or see IoT security on the horizon? A bunch of you guys, yeah. As you know, it's everywhere, and only very recently we're starting to see a lot of the attacks and the fallouts from having insecure systems. A lot of them, are in the industrial applications where they're very old legacy systems, never really were designed for security, or even let alone designed to have an IP address. And today they may have had an IP address module slapped onto it, what have you, literally in the field, or just a little warmed over update, that sort of thing, again, without security by design. Here's my overall agenda. I'm going to do a live attack on an embedded, this is an actual NanoPi with Ubuntu Mate operating system, embedded Linux. So I'm going to demonstrate a live network attack. And we have our machine learning-based detection engine on device, and it'll detect those. I'll show you an attack here or two at the end. So, any questions? All right. No. There may be. So as I dive into this, so please stop me and ask. So let's begin. I wanted to rewind a little bit. Interesting. We're going to use the smartphone device to go a little bit back in time, only because there's a progression here of sorts, right? So is this an embedded Linux device, or Unix device for that matter? I've got a bunch of Android phones as well. I'll hold that up. Essentially, this is an embedded Unix system, right? The iOS is based on the Mach kernel. Possibly, I think they merged. Steve Jobs merged in some Next OS back in the day. So, all right, Windows. Everyone has. I would think most of you have used a Windows PC in your life, right? That's starting to be phased over into mainly Mac for a lot of the younger folk. But here are some severe CVEs that have come out very recently for protecting Windows. You've got here EOP, heat buffer overflow, another EOP as well. And so this is literally in the past year and a half. So there's a lot of systems that are exposed. There's banking Trojans. These attacks are going after high-value targets, whether it's political or money, or typically it's they're really focusing on that high dollar return. So this is the Windows PC of the last year and a half. Oh, wait a minute. This is actually for mobile devices. So here's the thing with your desktop and traditional antivirus. People don't let that touch your enterprise, right, without antivirus. So why do they let your mobile device touch your corporate network without antivirus? So we actually have our machine learning-based technology for mobile. All right, so this is, again, just going back a little bit, giving you some history. So the mobile threat is real. This is the most safest phone in the world, right? The iPhone? That's what you mostly believe. Well, Apple has a really good spin on marketing their phone that there's absolutely zero malware. It's unbreakable. You can attack it. Good luck. Nothing will happen. You're secure, right? Well, they do a good job on the marketing spin. Officially, they say there's no bounty program. They say they'll deny it. But if you do some research and get into the know, they actually do have a bounty program. But they don't want you to know that because there's no need for it. There's no malware, right? Again, a bed Linux device or Unix, and it's invaluable. However, look at the trend over the past few years. We're now doing more of our packet surfing work on the mobile device and bed Linux device than the desktop. I just wanted to show you here, again, the embedded devices, whether it's a phone or tablet, or, again, I'm moving up towards IoT here. The CVEs are just increasing, and the severity is quite strong as well. So that's not a good thing for embedded devices. Just to give you a heat map here, This is for rogue access points or attacks that we've actually detected in the smartphone space. Lower Manhattan, there's a lot of money around there, as you know, Wall Street. And so, would you want to transfer, check your bank account around in this area here? I probably wouldn't, not even on an iPhone for that matter, just in case, right? Is it worth it? Can you wait? So the threat's real. And then almost half of people that have these devices, they're not even sure if they've been attacked, breached, that sort of thing. There's no way to know, right? Do you have a sensor? Do you have a detector? Does it run at machine speed? Is it, if it can run at machine speed, is it reactionary, trying to get signature updates from the cloud and try to keep up with 0 days? The traditional antivirus method won't allow for that, right? You got to use machine-based learning on device. As you know, a lot of the solutions are gearing towards machine learning. A lot of the younger companies, such as Imperium, we started off with machine learning. Okay, so I'm still in the past, but what you see here is you're going to have device-level attacks, network-level attacks, and application attacks. So if I have physical access to your device, I can hack your device via the USB port. Some of the governments want to access your possibly incriminating evidence via that way, attack the kernel, elevate privilege. Maybe they use social engineering. A lot of the attacks are started with the network attacks to do impostering, man-in-the-middle attacks, fake certificates, redirecting you to another website. You'd be surprised, right, how many people want to oblige and update that email client because the supposedly IT department says you have to do it, and oh look, it uses the logo to say, hey, update your email client, please. How many people don't want to be called up that, hey, my email is broken, be called up by the help desk, hey, how come you haven't updated your system? I just found out your email, your phone or your device gets email every 10 minutes from, say, Coca-Cola, so I'm going to use that logo and use social engineering. So you'd be surprised how it'll go from maybe 40% to 80% people will oblige. So again, I'm coming up towards the present here. The attacks are just increasing in short across the DNA vectors. There's been actually drones flown from Russia into Ukraine to spoof the troops out there. So here's a real life IoT scenario to say, hey, to get their GPS location and to send them messages. I mean, it's actually in the news and has happened in the past year. So the threat is real. Yes?
The kind of attacks that we're talking about in mobile phones are mostly have some social engineering component?
Yes.
All those have social engineering in it, so it's that you have some vulnerability in the iPhone that links and escalate the control of your phone or steal your password.
Right. It's a good question. So yes, there are social engineering is used, like I mentioned, to redirect you. Here's like a pineapple. I could use BetterCap image on a Kali image on the Mac. I don't have to have a pineapple. And so while you start over in the cyber kill chain with stage 0 to stage 6, stage 0 you're going to surveillance the network in the airport or in the coffee shop, for example. You just got off the plane. You are internet starved. You want to get your email. I'm curious, how many of you have stepped off a plane and tried to get some downloads and saw your graphics weren't necessarily populated, but the rest of it was? Maybe this was a year or two ago. Have you ever experienced that? And were you quick to put in your ID and password? Because if you did, you probably was attacked with SSL stripping.
No, I definitely didn't do that.
Okay, good. So it'll go from surveillance to narrowing down to a target such as you, and then seeing, oh, this person's device every 10 minutes is pulling Coca-Cola.com. Let me grab that logo. Let me craft a redirection Apache page, and then I'm going to narrow it down to stage 3 and then attack your device and spoof the router to say, hey, don't go to Coca-Cola. Next time you're going to come to this local Apache server, and then I'm going to put a splash page that says, hey, we're the IT department. Here's the logo. Please update your email client to be in compliance and to be a good, corporate worker. And the percentage will go from, under 50 to over 50. People hit yes. And then when you do that, you think, well, I can't download, in this specific case, say on the iPhone, I can't download apps. How many people think you can only download apps from the App Store on the iPhone? Okay, good. Don't raise your hand. So a lot of people think you can only do it, prove it to me that you can download apps from anything outside of the official Apple App Store. So you can, absolutely. Social engineering, one finger press. The weakest link, you just hit OK. I can get malware on your device that way with some social engineering. You can also sideload stuff if I have access to your phone. Maybe your company has their own little app store. So they're going to say, hey, you need to do this. It's a really neat tool. So there's a bunch of ways that the phone can be attacked. But yes, in short, social engineering, physical access, any other way that they possibly can, they will. So like I do another demonstrations where I can turn on your camera and your microphone on your iPhone without you knowing about it. I use some social engineering, but it surprises a lot of people.
Without using any social engineering, by use clicking on a link.
There are vulnerabilities without social engineering, yes. So it is going to be more device and kernel specific, such as the jailbreaks for iPhone that are only good on the iOS version, say 11.3.1. If you have 11.4, that jailbreak doesn't necessarily work, right? So yes, you don't have to use social engineering. All right. Again, there are items all over the news that keep growing on attacks on these embedded Linux devices. Again, this is a supercomputer in your pocket. You have a bunch of radios. You're actually taking this all over where you go with all the Bluetooth, the Wi-Fi, the LTE, and even NFC for that matter. You're saying, hey, I'm open attack space. Do you want to attack me, right? So it's supercomputer, and you're paying what, over $1,000 for it now? All right, so back in time, just wanted to give you that background because it helps understand where, in the industrial IoT space where we can leverage this technology. The IoT threat is real, absolutely. Here are just some actual attacks of recent. U.S. power plants have been attacked this year. Home devices with massive internet outage back a couple years ago. Again, this year the FBI warns the VPN filter botnet has infected routers. I think my home router has actually been infected. I can't be certain. I don't have our Z9 engine, our machine learning engine on my home router necessarily right now, because it'll stop working. I look at the syslog, and it has some weird error messages. I've Googled those. There's nothing that comes back. I can't do my job. I have to literally reset the router. This has only happened since about springtime. Sounds coincidental. I've had this router for about 2 to 3 years. Been rock solid. And this has been a consistent. So again, I don't really know if I'm being attacked, but man, something's happening. It's just not good. The Tesla remote access to opening the car, the Jeeps, all these other cars. Again, everything under the sun that's not a cell phone, laptop, or a building, right? That falls under IoT, as you may already know. So again, these attacks are increasing. I really do fear that there's going to be a grid takedown, and there'll be a bunch of loss in life that'll probably happen. And then I think these governments overnight will turn on laws to really start enforcing security by design for IoT devices. Today, you're really not seeing security by design for IoT. And so we'll see what happens there. Typically, companies want to get their IoT product to market without putting security in by design, because to have an SDLC software developer no security to do that is difficult. To have a security tester to find them is difficult. To retain these people, it's difficult. They want to get the product to market. They want some revenue coming in. They can update it in the field, right, et cetera, et cetera. They don't have anything to lose. There's no law enforcing them. There's no compliance at the federal level. Yet, only if companies are going to lose their brand image overnight, get sued by the HIPAA laws, et cetera, federal side, then they're going to actually try to do something up front to get by. So specifically then on the embedded operating system threat matrix, I'm going to focus on the network level and device level of attacks. Of course, the executable is a lot more of an open can of worms in general compared to remember the nice supercomputers that we went through, because those are APKs, IPAs, right? So they're bundled. Those bundles, those archives can be analyzed, and we do that with our product. But for the Unix side, it's a whole other animal that I think there needs to be solutions, and I know people are working on them for that. But today we can definitely leverage the network and device level attacks. You can elevate privilege on these guys. You can attack the device over the Wi-Fi network, which I'll show you as well. So any questions? So just showing you here, we've got product for smartphone. We have the SDK for your own app. This is the IoT side, which is everything else under the sun. The detection protection side that we have that I'll show you here is on the network and endpoint protection. And so our ML learning, machine learning based engine, we call it Z9. Again, we basically have ported it from the smartphone. We have the SDK, and I've worked on having it ported to a couple different embedded Linux devices. So again, it's real-time on-device detection of these threats and attacks. The engine is trained, the model's trained in the cloud and then downloaded to the device, because you can't really do real-time on the device because it'll just kind of kill the battery and you really can't surf much. So again, we've got to train the baseline for normal operation, which is billions and billions of data points in the cloud. We download the model, and then what we'll do is, I've got this other chart here to show you. So that's how the model is downloaded to the device, and then there's an update learning process for anything new that we may see in the field. There may be an operating system update that is pushed down to the device because there's augmented reality turned on. There's maybe other sensors or radios that are utilized on the device, whatever it is. So whatever your product's going to be in the IoT sense, you want to be able to have some learning process. So then you merge it with your original model and then download it back through the feedback loop back down to the device periodically. Just as a data point, we don't normally do that on a continual basis. There's no need for these devices. We may do that maybe twice a year. So, and then we've actually detected for an example, on the iPhone, the 0 days over the past several years. We didn't need the model to be updated. We still detected the jailbreaking as it's happening, whether it's a permanent jailbreak or a temporary jailbreak. And so, again, if you have all these devices in the field, right? Ask the practitioners, hey, how do you know if that device is being breached? The one that's controlling the electrical transfer or power plant node. How do you know if you're being breached? If you don't have a sensor on there, you don't know. I mean, it could be a persistent, enemy on there and just waiting for the opportune time to pull the trigger and take the whole grid down at once, right? So, yes?
Can you talk a little bit more about the SASE
statistical modeling?
I can a little bit. So basically there'll be a baseline that's understood on normal operation. Let's just say this device here. It's going to be a lot more unique for the use case for the industrial IoT side or the IoT side, because everything is so much more unique than this nice device here that we all are addicted to. So at least I am. So you have that baseline of behavior, what's good normal behavior, and then you have to model that with a lot of different perturbations. You know, are you going to go to this website over LTE? Are you going to then at the same time over Wi-Fi? Are you going to be, you know, backing up to iTunes or maybe over USB port? So there's a lot of these parameters that are put into place that you have to model statistically as, okay, this is generally good behavior. You know, do you have a lot of spurts on the CPU while you're doing this operation or that operation? If you're doing it on this, that should be fine if it's YouTube. If you're doing it with that, depending, again, on the specifics, that may not be a good thing. That might be an attack happening. So that sort of behavior is not easily characterized. We've done it for several years before it became a thing, right? So for the mobile. And then we're trying to leverage that for IoT. So then anything that's definitely like a jailbreaking activity, spoofing the ARP table, for example, that sort of thing, you know, that's a little bit easier to say, hey, that's obviously wrong. So that's a little bit easier for most people to say, hey, yeah, okay, that bypasses the regular behavior model. But for some of the other stuff where it's a slow attack that's happening, it really is then based on your algorithms and your expertise to get a good detection. So you don't want false positives, right? Overall things you want to minimize the false positives.
What's the learning period?
I'm not the, to be honest, I don't know the details of the engine. I think because they do that by design. We have our chief architects, Amish, yeah, that's not me. So even if I asked them, they'd probably just tell me this much more. So I do have some other stuff I can't show that's proprietary, but they don't give me that much. We could probably talk after. I do have a little bit more. I think there is some also on we do blog a lot on this. I think there's a couple good ones there is one, at least really good blog where he dove right into the statistical models and the different ones. Our actual Z Labs guys, the white hat researchers that we have, to keep up with the threat intelligence side. So yes.
Thank you.
Yeah, that'd be good. So yeah, that's the overall process. Very good question. Again, network and device level attacks. I think the application, as I mentioned, is a lot of work to a bigger problem to solve in general. So here it is, giving you an example. There could be passive or active monitoring of the device and the network around it. So there's a lot of solutions on the market that are targeting the home router and all the home automation, home security devices. You can put that into industrial setting as well. So you know this gateway, it can see it routes all the traffic that it needs to route. It may translate it from Zigbee, Z-Wave, you name it, Bluetooth, LoRa, proprietary RF. And so are you scanning at the IP layer? Are you scanning at the layer 2 or at the RF layer, right? So there's many layers there, but in general, a lot of these solutions are going to try to get a characterization of the traffic to see what's normal. And they may do passive, they may use active, they may actually put an agent on the router, or they may put a span port and copy all the traffic to a local hardware device, the cloud, to do some behavior analysis. For the network side, so a lot of the offerings kind of see what devices are there, check the firmware against the database to say, hey, this is older firmware. I'm just talking about what's out there that's real similar. And then, again, we're trying to protect the endpoint, not just the router, but the endpoint. So you could also put our engine on the endpoint, because a lot of these endpoints have embedded Linux, right? The Mirai surveillance cameras that came out, what is it, a year and a half or 2 years now, is an embedded Linux daemon on the device. So you could either have the, that local router try to detect anomalies of those devices, or even just try to put the engine right back on that end node. So ideally, you want to put the detection as further out as possible, earliest coming into the system towards the analog side. And then again, you can actually attack a lot of these devices via the analog side. So for example, if it's a home or building security or any type of that sensor that uses a magnet to know if the window or door is open or closed, you can easily bypass that read switch by putting a magnet right there, and then open the window, and there's no detection. That's on the analog domain. It'll get converted to digital, signal message sent up, stream to the rest.
Have you adapted some of this to embedded systems in vehicles, so like CAN bus systems are very similar to what you're talking about?
Sure.
Where the sensors on the car are now getting more integrated with the smart system, but it operates on a low-level signal that...
We can, and we've actually ported this to QNX.
You have, okay.
So QNX has been a mainstay of those car modules, although that's behind the dashboard, not driving that nice LCD on the front. But yeah, absolutely.
Like every year it's...
Oh yeah, sure, and it's, I hear that like QNX in the car has been there right since, even the 80s, is nowadays not necessarily, they're just putting bare metal devices, again, behind the dashboard. And then in the dashboard, it's still a lot of QNX with the sexy user interface and that thing. And that.
You've seen some good traction with the models that you're using with that.
Well, I can't, I don't have specifics that I can say. I just know that we have ported it to QNX. Sorry? Can I wink? I know that we can actually detect these attacks again instantly, right? So, and reliably. So it's very attractive to a lot of these applications. It just depends on, some of these people don't, or companies or applications don't feel there's a need yet. And if they do, they don't really want to pay for it. And then if they do, they don't want to design it in. I mean, there's so many, it's like a whole shift that we're going to have to do by implementing security by design.
Question.
Yes?
Are there any plans to integrate or create or partner with MDM solution providers like AirWatch and VMware or others that have mobile device management solutions that apply the security policies encryption on the device? And in addition to that, if you could have the machine learning engine running as a preventative or detection monitoring mechanism, I think that provides some additional layer of security for protecting corporate data.
Are you asking about the use case of the smartphone or IoT?
Yeah.
So I left that off. Absolutely. We've got, we work with AirWatch, Mobile Iron, all of the major MDMs. Specifically with Mobile Iron, you don't need their agent and then our standalone app, which runs at, we don't need root access or system level. We've now, with the SDK, put it into the Mobile Iron MDM agent. So you don't have to talk with the API to the Mobile Iron backend and say a threat was detected and they push down a remediation action. It's all local on device. So I can attack your device while it's disconnected. If you are connected, I can be sure that your device doesn't talk back to the AirWatch and Mobile Iron MDMs or anything good for that matter. So to have our engine built into the Mobile Iron, and it's only with Mobile Iron right now, it's just so natural. And so when you deploy mobile threat defense with the single agent, there's no prompt to the user to say, hey, you need to hit OK and allow this. It gets turned on in the background with the key. And so there's a 100% take rate for line of business devices that are managed by the business. Bring your own device. You may want to say, hey, I don't want Big Brother. And it's you and your company's use case to work that out. a lot of them say, hey, we won't let you take a personal device and access corporate email unless you enable the mobile threat defense engine, say from us. So yeah, I left all that off. But the challenge here is how do you do it for Linux, right? And so there are things you can do. You can have our ML engine on the embedded Linux application. You can give it root level access, and so it can do some remediation on its own without an MDM, right? I mean, there's no MDMs really for embedded Linux today, right? I mean, there's some stuff coming out, but there's nothing big like the enterprise side. So, on these devices, we run as a regular application with we only look at system metadata. We don't do any deep packet inspection. It would be the same in this case, but we have the option to give it some root level access to do some of its own remediation. So that's part of our architectural feature list. Yes?
Something you touched on with the metadata is that also means you don't inherently have to decrypt, because you can catch the metadata of what's going on.
Yeah. Yeah, so we're running as a regular process. We don't have root level, so we can't even do DPI, and we don't need DPI to do what we do to detect bad behavior on the device. So, I mean, a lot of enterprises, or for that matter, this is a little different. I think we got to see how the market grows. If they're going to have an MDM that really gets taken on as a more or less somewhat of a standard out there. I mean, it's a whole wide open field with different versions of Linux and target devices. Like there's all kinds of different, even though a lot of them are ARM-based, it's a whole lot more, it's a lot harder to support with the compiling for that tool chain for that actual target and that version of OS versus, I mean, look at Android, right? Fragmented versus, the iPhone side. Again, Android is fragmented because of the carriers, and Apple's kicked that factor out of their equation to update their phones. But yeah, it remains to be seen how. You want to do security by design. So if you do that, how do you know you're breached? You still need a detection sensor on the device. You kind of need both, right? You want to harden it, ideally design it securely at the beginning, which is, monumental, and then you want to have a detector on the device to know if you are breached. So consumer products don't necessarily care. The government absolutely cares. They need to know right away. So enterprise, they're definitely, buying into the solution because they're being attacked. You can pivot, as you can pivot off of these devices. They're pretty powerful. They got Linux. They got network ports. I mean, they got access typically to the rest of the internal network. Just, get access from the outside via one of the radios, what have you. So, I mean, the attack space is huge. Good questions. Any other questions before I bring over my live attack here? All right, so I've got Ubuntu. It's actually Ubuntu Mate on this NanoPi. So it's a popular hardware platform like the Raspberry Pi. It's a bit thinner. Kali Linux does support it. I actually have Ubuntu on here. And it's currently running our Z9 engine. And this is just the detection engine running in the background. That's all what this scrolling text is. Let me end my show here. Okay, so, all right, I've got that, and here's our console in the background. And I will go to the threat log. And then I have a better cap window. I have a couple windows over here that I'll show. So, okay, so I've got better cap command right here. Let me expand that, make that larger for everybody. And this is going to attack the IP address of the NanoPi right here. This one is going to do a ARP MIDM attack, a man-in-the-middle attack to the device. So what you're going to see is, can separate that. Okay, you see something is triggered. Essentially, this attack is triggered. Our engine, I think it's actually resetting to do a hashing of the file system. And then what we'll find is the alert will come back to this dashboard within a few moments right here. It may take the way I have to essentially kill the attack so that the forensic data, the threat alert, can actually then get back up to the cloud. We do have an Apache daemon on the device. I don't have it. I don't have it going. So then I can actually point my browser to the Apache server on the device. But let me kill this attack. This should be sufficient. And then within moments, it'll send it back up. Now that doing a man-in-the-middle attack on its only lifeline back up to the internet. So that's a man-in-the-middle attack. An ARP MIDM attack, and then this one here I'm going to do SSL stripping using BetterCap. Typically on the device you would have to generate some traffic going back out to then get spoofed or to maybe get your SSL session stripped, right, from HTTPS to HTTP. So that's why I'm going to wait here for a minute or two. If I had it connected to the HDMI, I could actually bring up a browser and do some surfing. But see right there? Okay, so we have some pings that happen automatically, and so then that will generate some traffic for the SSL to get stripped. So I'll wait a few more seconds on that, and then I'll kill the attack. So then the alert can get back up to my, we call it Z console. Let's take a look if the first attack has come back up. Not quite yet. Not quite yet. Let's see here. My device should be active. Yeah. Oh. Don't you love live attacks? So yeah, it normally takes about 2 minutes. And I've killed. Oh, I did not kill this. Sorry, I thought I did. So that essentially wraps up my presentation and demonstration. I'll wait another moment or two. We can check for the alerts to come back up. You can see some previous stuff I've done. And any other questions? We can have any other question?
So the dashboard reporting
comments?
Sorry. Thanks. If you're integrated with an MDM solution, so that the administrator gets like a holistic view of whatever is happening on the device from a compliance standpoint that the MDM provides. Oh, so you just add that, and so you can add the dashboard reporting to the MDM, or you can get a singular view of all whatever is happening on the device.
Right. So what I do here is I do a one-time integration of our Z console with, say, Mobile Ion or AirWatch MDM, and so then it's synchronized on a regular basis. For the single pane of glass, that's on some of our products as a plug-in to the MDM's console page. You can always log into this one off to the side. You typically set up but you have to set up your policy, your detection policy here, set it and forget it. You tweak it maybe every 6 months, depending if there's new attacks happening or new vectors that are opening up with your use case. And then so basically the remediation side, you do that on the MDM side. We can do some remediation, essentially turn off Bluetooth and Wi-Fi because we're only a regular app. On the iOS side, you cannot turn off Wi-Fi by kernel design, so we do a network sinkhole to do the same thing. So then for anything, you know, to really enforce it at the system level, such as remove apps, remove VPN, remove email access, anything of that, you know, wipe the device, lock the device, track it, lock it, and wipe it, that the MDM likes to do, can do, you can absolutely set it up. So, under policy, so what I'm talking to here is the device action. Upon detection, I can do network sinkhole, disable Wi-Fi on Android. I can take advantage of Knox to do some more things on, only because Knox on Samsung has that capability. And then on the MDM side, threat detected, put the quarantine label immediately. That means remove all these network access and apps. And then when the threat goes away, remove the label, take the device automatically out of quarantine. And so this workflow is automatic, very low touch. You know, that's how we do it on enterprise today. It's just doing the whole new animal called, you know, industrial IoT, home stuff. I think there's a need for that home router. I think there's a market there. People, I think, would pay for that. I probably would too, actually. But yes.
This works with Knox, but since that's based on security enhanced Linux and all the, I think it's in the last 2 years at least, that all the versions of Android have SE Linux in them, does it work with that? And then the other part of that is, I think I read somewhere that Samsung was pivoting away from Knox. So are you going to be able to use the same integration use because Knox being built on SE Linux, that you can use that with being able to enforce things with SE Linux on other Android?
So, right, very good question. There's a lot there. Android does implement SE Linux in general. Samsung has like layer 1 secure boot tie-ins with their extensions to their version of Android to do stuff with the hardware, the HSM and secure boot, and to do management to where you can't. If I have Knox turned on, there's definitely a lot of different levels of Knox. For one, it's huge. They have a lot that they offer. If I turn on Knox on your device, you can. There's a feature within the umbrella to say, hey, it will even restrict you from updating or putting your own firmware on your phone.
Can't sideload it.
Well, that's sideloading an app. Well, you can technically sideload the firmware image, but yeah, it actually restricts you from updating the firmware of your phone. It can change the boot screen or restrict the boot screen from being changed on your phone.
Where if you're loading it up and you're trying to force the firmware onto it.
Yeah, with ADB, or I guess Samsung has their what they call Odin tool, and everyone else uses ADB, Android Debug Bridge. So yes, Knox is a huge umbrella at many different layers, and then it does depend on the API. I understand, you know, you have to license certain API, I think, to get to that HSM and the secure boot level. For the general usage, you just have to have an agreement with API. So there's access if you're in the know of a partner. There's paid for license to the other versions of the API. And then again, there's stuff that's dependent on certain versions of phones. Like you said, the last couple of years, I think they can restrict, like I was saying, you can't change the firmware, you can't change the boot logo. You go back a few more years, it's probably not implemented because it's too old. Now, you said they may be moving away from Knox.
I read something like that, but
It's
like you're doing away with the security, but there's some like
yeah.
some kind of proprietary Knox that we just want to use SE Linux and full enforcement.
That's possible. With the Android Pixel phone that was announced a couple weeks ago, Android was not even mentioned at all from Google. The Android OS term was not even mentioned. The word was not even mentioned during their press release of the Pixel 3, right? Because rumor is that they're moving from Android to kind of Chrome, Fuchsia, right? So, yeah, it's possible. I don't know. I really don't know. It's a good question.
That's really interesting, though. You can see visually here with non-technical view that you have a lot more capability with the Linux side. And Apple, you just have to trust to verify and try and detect.
Right.
They let you dig deep in to do
I don't have a profile on this console. Oh yeah, because this is the IoT console. But like, it just takes one finger press. I will say that the iOS kernel architecture is a little bit more secure than Android, right?
You have to trust it.
But it takes one finger to approve of an iOS profile. And there are 27, 29 different ways to have a profile. And that can and will bypass everything on the phone, even an MDM in many ways. So, then the MDM can only have like the first level of detail. What is that profile doing? Oh, it's free VPN, free games. Well, they're inspecting, nothing is free. There's no free lunch in America. So they're either inspecting all your packets, but the consultants want it because they want to serve freely and not have to go through the employer's sniffing network. So there's all kinds of profiles to where, again, it just takes a single finger press and it bypasses all the iOS controls and the MDM controls. It's amazing, right? And there are some attacks happening that way, but I can see that escalating even more because they're pretty involved if you look at iOS profiles. But we actually will, via the MDM, we'll have a list here of what's managed by the MDM and what has been like side approved and not come up through the MDM. And so they'll be marked suspicious, and you got to, like you said, trust and verify. The mobile administrator should do that. But what they can't necessarily do is have any more than the first level of details of that profile. So they'll have to call the user and say, hey, you got this suspect profile on your phone. Can you open it and take a picture and send it to me so that we can investigate it further? I mean, it's a manual process. It's a big loophole, right? So for people to say, no, there's no way to siloed malware, everything is great coming through the App Store. I can click on a profile. I can go to a website and download app because a profile is pushed and I've accepted it. So again, the threat's pretty real. And that's some of the other attack that I use at different demonstrations I use with some social engineering to turn on your camera and your microphone without you knowing about it. Right? It takes advantage of some of these vulnerabilities. Our engine will detect it on the fly, but so let me see here if the threats have come in. I don't think they have. So, yeah, it worked. Like, it totally worked. You can see some of the history I've done here. It's worked. So, SSL stripping, ARP attack, a MEDM attack, Murphy's Law, just one right now. It literally has worked. Look at my timestamps. It's worked. I have sleeping trouble, so I'll sleep, work, and the clock almost doesn't, sun and the clock almost doesn't matter. But
It's okay, we believe you.
thank you.
Making the souffle.
So that's all I had. And thank you for your questions. Thank you. Thanks.